Okay, let me give you guys some practice now. So here, find the indefinite integral of this. Remember, the hard part is in making your first guess. Because we are just starting out, I'm going to guide you. I'm going to ask you to make this your first guess. So make this your first guess. Differentiate it. You will get blah blah blah, and then make the adjustment here so that you will get this coefficient here. Well, anyway, press pause and have a go. Okay. So to do this here, make this your first guess. If you differentiate this, it will give you 7e to the power of 7x here, but you don't want the 7 here. You want the 3. So if you make this adjustment here, if you make this adjustment 3 over 7 here, now when you differentiate this, it will give you 3 over 7. Remember, this thing here goes down here. So times 7, and then e to the power of 7x here. This 7 gets multiplied to the top, and then you can see that these two will kill off each other, leaving you a 3. The point is that if you differentiate this here, it will give you this perfectly. Okay, so the answer here will be 3 over 7 e to the power of 7x here. And because we need to represent the whole collection of antiderivatives, we need to put plus c in here, because we need to represent the whole family of antiderivatives. Okay, so this here will be your final answer. And remember, at this stage here, you don't really understand the significance of this dx thing. Okay, this will make sense in the future. But the point, just roughly speaking, this dx here, well, when you look at this here, if you differentiate it with respect to x, that's really the significance of this x here. The significance of this dx here. If you differentiate this whole thing here with respect to x, then it will give you this here. But don't worry about this dx thing for the time being. It will make sense in the future. Okay. So next one here. So find the indefinite integral of this here. So because we're just starting out, I'm going to guide you. Make this your first guess here, and then visualize this as a bubble here. So when you differentiate this, it will be e to the power of the bubble here, and then you've got to use a chain rule and multiply with the derivative of the bubble itself. So this will be minus 2x here, and then make the adjustment to get what you want. Okay, well, make the adjustment. Well, for your first guess, start out with this guess here. Okay, so differentiate this and then make the adjustment. Okay, so press pause and have a go. Okay, so when you differentiate this, it will give you e and then the bubble intact, and then you've got to times with the bubble itself. So that will be times with the derivative of the bubble itself. So that will give you this. Tidy it up, it will give you negative 2x e to the power of minus x squared. But we don't want the 2x, we want this 3 here. So let's make the adjustment. You see, if you make this adjustment here, then that, now if you differentiate this, it will give you this thing here. Okay, so hang on, let's just move this minus up here. Same thing. So it's negative the whole thing here, here. So let's try and differentiate it. So starting with this, if we differentiate it, it will be minus 3 over 2 e, and then the bubble intact, and then we've got to times with the derivative of the bubble itself. So that will be minus 2x here. Okay, because we need to times with the derivative of the bubble itself. So maybe you can get this and times it. Well, when you differentiate this here, it will give you this thing here. Okay, so the answer here will be equals minus 3 over 2 e to the power of minus x squared, and then because we need to represent the whole family of antiderivatives, we need to plus c here. So this here will be your final answer. Okay.